Okay, number 70. Ask you use bond energy, calculate this reaction's enthalpy change. Two more is C2H6 react with 7 more oxygen gas, produce 4 more carbon dioxide and 6 more water. All reactant and product are gas. Be honestly, this one for you guys is very difficult. And this is organic molecular, so you don't know the structure at this moment. This we call agent. We need a Lewis structure because we need a Lewis structure to count how many bonds for each type of bond. Right? So there is a 6 carbon hydrogen single bond plus 1 carbon carbon single bond. Of course, we have 2 more there. Oxygen is 2 oxygen double bond. Right? Carbon dioxide. You are required to know how to write the Lewis structure for carbon dioxide. We just learned, right? Carbon in the center, oxygen surround it. 2 double bond plus 6 water. Water. Remember, I show you water Lewis structure. Yeah, that area. Okay. So water, you have 2 oxygen hydrogen single bond. Right? So to write the Lewis structure, we can easily count how many bond for each type of bond. So for this case, there is 1, 2, 3, 4, 5, 6 carbon hydrogen single bonds. 6 carbon hydrogen single bond. But don't forget, we have 2 in front of it. There's 2 more. This single 6 carbon hydrogen single bond is for each molecular or 1 molecular, right? You need to carry this 2. So actually, its total is 12. Plus 1 carbon carbon single bond, right? But that's 2 more. So this is 2 times carbon carbon bond. We count this as bond energy, so this should be bond energy of carbon hydrogen single bond 2 times 6. Right? This is bond energy of carbon carbon single bond. Right? Oxygen 7 oxygen oxygen double bond. Okay, so reactant, all these bonds must be break down. So this is absorb energy, so positive reactant. Product for new bond, this will be negative, so minus it. Bond energy itself always positive because you break down bond always need absorb energy. But during the reaction, this actually is the opposite, is the form new bond. That's why it's negative. Okay. So 4 times each carbon dioxide, you have 2 carbon oxygen double bond. So 2 carbon oxygen double bond. So total is 4 times 2, right? Plus 6 times 2 oxygen hydrogen single bond. Right? Now we just take a look. This is the total enthalpy change for this reaction. Just take a look. bond energy. Okay. So take a look at the table from the textbook. So carbon hydrogen single bond is 414. Carbon single bond is 347. Plus 7 times oxygen double bonds 498.7. This is total energy we must input. Then oxygen in carbon dioxide. This is bond energy is 799. Oxygen single bond from water 460. Then the rest just give final answer. Use your pure calculator. You can get this answer is negative 2759.4. Unit is kilojoule. Okay, so first is formula. So it's all reactant. You need to break down all these bonds. So first of all, you need to write Lewis structure. Then you can count how many bonds from each type of bond. So this is carbon hydrogen 2 times 6 in each molecular. This is plus 1 carbon single bond, 2 more. Then this is oxygen double bond. You have 7. Then count how many bonds in the product part. So product is a forming bond. So this forming bond is release energy. So that's why it's negative. So carbon dioxide, each molecular you have 2. Total four moleculars, 4 times 2. And water you have 2 oxygen hydrogen single bond. Then you have 6 molecular, so 6 times 2. The rest is from the bond energy from the table provided. We have a table in the text. Okay, find this value. Then just give answer. So are you okay with this example? Okay. Now we have 7 minutes left. Do you have any question? If you don't have any question, I have another one. Let's see. So this may not in the homework. We learned this, right? This is Lewis structure. Based on this Lewis structure of carbonate, CO3 2 minus is carbonate. Can you figure out formal charge for each atom? We have 2 or 4 atoms, 1 carbon, 3 oxygen, right? Can you calculate the formal charge for carbon and 3 oxygen? We have 3 oxygen, so you need a label then. Carbon or 1, you don't need a label. Oxygen, we have 3. So they may not the same, right? For carbon, formal charge. So first of all, how many valence electron for isolated carbon? This means not in any structure. Four, yes. From group 4A is 4. Is there any lone pair? No lone pair there, right? Then the bonded, the shared with others, that's why it's 1/2. Bonded valence electron, double bond is 4. Single bond 2, we have 2 single bond, right? 4, 2, 2. 8, this 8 is shared with others, that's why only half assigned to that carbon. Then what is the result? 0, right? So carbon is 0. Then what is oxygen 1? How many valence electron for oxygen not in any structure? Yeah, 6. Group 6, 8, so 6. And how many lone pair? 4 lone pair, 2 lone pairs. Each lone pair is 2, so total 4. So this 4 not shared. So this definitely belongs to this oxygen. And this double bond is shared. So 1/2 of double bond 4 electron. But this is shared with others. That's why this is 1/2 of 4 belongs to assigned to oxygen. So also 0, right? Now how about O2? O2, isolated O2, of course 6. Then how many lone pairs in this structure? O2 is 6 electrons. 3 lone pairs, 6 electrons. Definitely belongs to this oxygen. Single bond, 1/2 of 2. Single bond is 2, but it's shared with others, right? So 1/2 of 2. So this one is -1. Then how about O3? Isolated oxygen, always 6, right? So this first number is just take a look at periodic table. Then lone pair, not shared, also 6, right? Then the bonded, also 1 single bond. Then what is the result? Also -1, right? So you find this double bond oxygen formal charge is 0, and these 2 single bond oxygen -1. Carbon also 0. They're different. 3 oxygen in this structure, they're different. Okay, double bond oxygen is 0. Single bond oxygen is -1. Are you okay with this? Yeah, now only 2 minutes left. We cannot give another example.